about Swati and how she's been through the journey. So Swati Yadav has a total experience of 8 years, right, in Java FSD, web development. 2 years of experience as a certified trainer in Java web, Python, data science. Handle classroom delivery and curriculum development for K-12 segment for web development, Python, and Java FSD curriculum development and training for working professionals as well. So she comes in with a lot of experience and a lot of insights on working on large scale projects. So over to you, Swati. Good morning.
Hi, thank you. Thank you, Pradesh, for introducing me. So hello and welcome all to our today's webinar, okay, which is based on solid design principles that, every developer should know for designing robust applications. And I thank you guys for taking your time today on a Saturday morning and for being here today with us virtually, right? Okay, so the thing is, the agenda for today is to get to know the first 5 principles of object-oriented designs, which are the solid principles. It's an it's an abbreviation of it or an acronym, which basically stands for. So I'll take you to a text file. Just a moment. Also, I would like to remind you guys that your Q&A option is available. So any question that might arise, while we are taking up the topics or even after we are finished. So make your communication through Q&A. I hope my screen is visible to everyone. Now we are going to start with solid. And solid is a popular, set of design principles that are used in object-oriented software development. It's used in object-oriented software development, and you can use this design principle along with the, n number of or numerous programming languages out there. Today we'll be looking it through JS. Or JavaScript, but you can use it along with Python, you can use it along with Java, PHP, any. Okay. So solid is a popular set of the popular set of design principles that are used in object-oriented software development. And solid is an acronym. Basically, it stands for 5 key design principles. And what are those? The first is your single responsibility principle. Second is your open close principle. The third is your Liskov substitution principle. Fourth is your interface segregation principle. And fifth is the last one is dependency inversion principle. So these are the 5, the solid is basically, it's not like solid state of matter, no, but it's an acronym which, has this meaning of 5 terms that you will see. First is single responsibility principle, then open close principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. I mean, like, these are the design principles that you have when you are, working with object-oriented programming. Now, solid principle, to give you a brief history of it, it was developed by Robert C. Martin. And it came around in, I think, in year 2000. Okay? he introduced an essay on it, which was design principle and design pattern. Okay, so although this acronym of SOLID, it was coined later, but the concept was introduced in 2000 with an essay by Robert C. Martin. So in his essay, Martin, what he did was he acknowledged that successful, softwares, they will change and develop, right? Any successful software, it should be able to adapt, change, with the advancement in technology, maybe the data which is incoming as you're proceeding forward after year. So it should not be like that after every year you have to build a new software. It should be adaptable. Now, as it changes, what happens it becomes increasingly complex sometimes to maintain. And without a good design principle, Martin, he warned that software will become fragile, it will become rigid, immobile, and viscous. So the SOLID principles were developed to combat these problematic design patterns, which will enable us to maintain, quality softwares. The broad goal that we have for SOLID is to reduce some dependencies so that people or engineers or developers, they change one area of software without affecting or impacting other areas, right? So if there are different modules, I mean, like if you guys are from development, there are different modules when you develop any software, right? Any change to one part of a module at any given point of time should not affect the whole working of the your product, right? So additionally, they are intended to make designs easier to understand, these principles, and easier to understand, maintain, and also to extend. Ultimately, when we use this design principle, it makes it easier for the engineers, for the software engineers, to avoid issues and to build adaptive, effective, and agile softwares. Okay, now, these principles, they do come with a lot of benefits, but still following the principles generally, it basically leads us to write more LOC, lines of code. And often the code is also complex. This means that it can extend the design process and make development a little tad, or you could say a tad bit of difficult sometimes. Now, however, this extra time and effort is actually worth it, because what it does is it makes your software so much easier to maintain thereafter, test, and even extend or adapt to the changing needs. Okay, but alone following these principles is not a cure-all, you could say, a method, and won't avoid any kind of design issues. I mean, like there are many issues which come in, but then yes, it makes your task a little less difficult thereafter. Okay. I'm so sorry for that. Okay, now these set of 5 design principles, they help softwares to be robust, testable, extensible, and maintainable object-oriented software systems. Okay, and each of the 5 principles which is there, it solves a particular problem that might arise while you're developing the software systems. So let's start with each one by one. The code base, please remember, the code base with this principle will, it's going to increase. Okay. So now starting with the first principle, which is your solid responsibility principle, SBR. Okay, now the single responsibility principle, it states that a class, module, function should have only one reason to change, meaning it should do only one thing. Please do not, kind of put everything onto it. Oh, single responsibility. I wrote solid responsibility. Single responsibility. Thanks. So single responsibility principle, it states that your class, module, function, it should have only one reason to change. Okay. For example, a class, I'll show you a class. Here. Now, for example, this class that shows the name of an animal should not be the same class that displays the kind of sound it makes and how it feeds. Do you see that? It gives me a name, the feeding type, the sound made. Everything is into one class. Okay. Now, this is a problem that will come up. Now, this is a very simple task, and you would be like, this is so simple. The question is so simple. The example is simple. But to understand this principle, we have to, kind of understand it with a simpler examples, right? Here, you would not find a problem, but maybe after, you're designing some hefty products, there, if you're putting everything into one class to handle everything in one class, there the problem will come. Your code would be complex, making changes into it would be complex, right? And to understand it at one point, again, that would be a difficult situation. Now, this code that I have in front of me right now, it violates the single responsibility principle because the class that's responsible for printing the name of the animal is also responsible for the sound the animal makes and also for the type of feeding it, right? Now, to help simplify this or to fix this, what we have to do, tell me, how can we simplify this? How can we simplify this? I do not want to put everything into one file or into one class. Now, how can that be tackled? Can I have different classes? Can I have different classes? Let's have different classes. Like I'll have class animal. And in class animal, first you're going to have a constructor where you'll have the name of it, then assign it, this dot name equals to name. Now after this, in this, what I only want the name, right? So I can again make a method, give any name to your method, your function, not a problem. And then you can just log the name, console.log. Is to get this dot name. This is one class. Now let A1 equals to new animal. And here you can give any name, right? Like, let's say lion. So now you're handling only names over here. A1 dot that's it. Save it. Let's check. This is your rp.js. The name of the animal is lion. Okay, so we've got only one thing out from it. If from the earlier one, you were getting everything out from just single class, which was there. Okay. Now, if you want to handle sound, now you can even handle sound over here. For that, you are again going to create another class. Okay. So let's say you have another class for sound. Okay. Now, in your constructor, you need to give two things. First, which is the animal, and then what is the sound, right? Then only you can identify it. So name and sound made. We have two things over here in the constructor. We are taking two values from here. Now the next is okay. Now the next is to write a method function basically. Now sound, so I can simply just do console.log and let's have this text. This dot name and whatever is the sound made. This dot sound made. Okay. Now the next is create an object. Let's say a2 equals to new sound. And again, I'm giving lion and rose. Then a2 dot sound. Has it not taken? Okay, no problem. That takes. Okay, let's. Okay. Now from here at the bottom, do you see that the sound made by lion is road? Okay. Or the lion roars. Anything that you want to print, you can get that. Similarly, if you want a feeding class, then you can also make a class for feeding. Now, this way, each of the class is doing only one thing that you see. The first class that I have over here, it's only giving me the name of the animal. The second, it gives me the sound of the, the sound that particular animal it makes, and so on. So whatever, so this principle states that the code will be more better and the readability will be also, will increase or will, and it will be easier to maintain. Though, what do you see over here? The LOC, it has actually increased. The lines of code, it has increased. But still, to understand it later on, maybe for even complex code, it will become easier for us to maintain and read. So a developer who didn't write the code, right, can come to it and understand what's going on quicker than having it all in one class. So that is what your single responsibility principle, it states that, this Robert Martin, the one who, gave all the design principles, he summarizes this single responsibility principle by mandating that a class should have one and only one reason to change. Following this principle means that each class only does one thing and every class or module has one responsibility for one part of the software's functionality. Okay, so more simply, each class should solve only one problem which is in hand. Okay, so it's a relatively basic principle that, most developers are already utilizing to build code, and it can be applied to classes, to software components, modules, functions, and microservices. Utilizing this particular principle, it makes code easier to test and maintain. It makes software easy to implement, and it helps to avoid unanticipated side effects of future changes. Okay. So this was your single responsibility principle. Then the next which comes is the open closed principle, which is OCP, which I'll make you understand from another set of example. Now the open closed principle, it states that classes, modules, and functions should be open for extension, but closed for modification. OCP states that classes, modules, and functions should be open for extension, but closed for modification. Now, what does it exactly mean? Right? So this principle, it might seem to contradict itself. By open for extension, you're extending, obviously there is a modification into it, but then you're saying there should be no modification in it, right? Let's try and make some sense out of it. That it means you should be able to extend the functionality of a class, any module or function, by adding more code into it without modifying the existing code which is already contained in it. Okay. This states that you should be able to extend it. Matlab, you can bring the changes into it, you can extend it, but without, kind of modifying or deleting or, removing the current functionality of it. The idea of open closed principle is that existing well-tested classes will need to be modified when something needs to be added. Okay. Yet changing classes can lead to problems or bugs. Instead of changing the class, you simply want to extend it. Okay. With that goal in mind, Martin, he summarized this principle that you should be able to extend a class behavior without modifying the class itself. Okay. Now, following this principle, it is essential for writing code that is easy to maintain and revise. So your class will compile with this principle if it is open for extension, meaning that the class behavior can be extended, more things, more functionalities can be added to it, but closed for modification, meaning that the source code is set and it cannot be changed. So at first glance, these two criteria, they seem to be inherently, contradictory. But when you become more comfortable with it, you will see that it's not as complicated as it sounds. The way to comply with these principles and to make sure that your class is easily extendable without having to modify the code is through the use of abstractions. Using inheritance or interfaces that allow polymorphic behavior is a common way to comply with this problem. Now, regardless of the methods that we use, it's important to follow the principle in order to write code that is maintainable and revisable as well. So let's understand, let's see the code that I have in front of you. Now, this particular code where I have a class animal with name, age, and type, and then I'm using a switch case, and there are different cases for the type of animal, and I'm printing it out, right? What that cheetah runs at 130, lion runs at 80 mph, and elephant, and so on, right? So now here, this code, it violates the open closed principle, because if you want to add a new animal type over here, what will you do? A new animal type will mean that you need to modify the code, modify the switch statement over here. Now, normally, if you're using a switch statement, then it's very likely you will violate the open close principle. Because if you want to add something into it, you're going to modify the code, existing code, change over, right? Now, how we can refactor this? How this code can be refactored? I'm going to have different classes over here. Okay, so the animal class that I have, it's obviously going to have some name, age, and type, or the speed rate, because we are working with speed. It should be speed rate. Okay, speed rate, and in get speed, I'm going to return the speed. Okay, return this dot speed rate dot get speed. Fine. This is one class. Now, all the other things that need to be managed now. I'll have a class speed rate. And in this, I'm calling get speed. Fine. Then I'll have different classes for all the different animals which are there. So let's say I have a class for cheetah. Okay, so class cheetah speed rate extends. It just extends speed rate. Okay, now do you see there are interfaces? There is inheritance going on. Now you can give your own implementation of speed rate. So theta is runs with what is the speed rate? 130, I suppose. Okay, so you've given 130 over here. For all the animals, you can simply just do this. Now, once you are done, you just simply have to create. You have to create the the objects now. Okay, if you have to create the objects, so I can do that with class C equals to new animal, and I can put a cheetah over here. I can give the age of the cheetah. I can now give the speed rate. So for speed rate, I'm giving new cheetah speed rate. Because this is the object, the C. Let me see. Const. And the next is to just log it, console.log. And then you can simply just log the cheetah name, c.name, and then you can do some runs and the speed of it. So that would be c.get speed, like this. Okay, I did make a little trade. New data, okay. Animal. C equals to one moment. Just a moment. Let me check this again. Okay. This is fine. And this should be Okay. C dot name and C dot get speed. Okay, perfect. Okay, so let me just share it again. Now here, this is OCP2.js. Let's see what do we get with OCP2.js. So it gives us the output as Cheetah runs up to 130 mph, right? So this is what we were trying to do. We have this class, and in that we've given a method speed, and then we are using that in other classes, and then we are doing inheritance over here to extend this class. So this way, if you want to add any new class or any new animal, suppose, you can simply just create a new class that will extend the speed rate and pass it to the animal constructor, as we've done over here, without modifying the existing code. So the rest of the code will always remain the same. Only there will be an additional, overhead of adding a new class and then using it. This example now confirms to open close principle. The next which comes is the Liskov substitution principle. Okay. Now, of the 5 solid principles that we have, the Liskov substitution principle is perhaps the most difficult one to understand. Why? Because this principle simply requires that every derived class which is there Liskov substitution principle. Now this, it's the difficult one, as I said, and it requires that every desired class should be substitutable for its parent class. Okay. Every derived class should be substitutional for its parent class. Okay. So this principle is named for Barbara Liskov, and who introduced this concept of behavioral studying in 1987. And Liskov herself explains the principle by saying that what is wanted here is something like following the substitution property. Now understand that if for each object O1 of type S, if there is an object O2 of type T, such that for all the programs defined in terms of T, the behavior of P is unchanged. When O1 is substituted for O2, then S is a subset of T. So this states that for each object, which is O1, okay, and this is of type S, there is an object O2 of type P for all the programs which are given in P, okay, and they are defined in terms of T. Now here the behavior of P is unchanged. Behavior of P is unchanged. Okay. When O1 is substituted, when you substitute O1 for O2, okay, here then what happens is S will be a subtype of T. So this is what it states in simple terms. While this is a difficult, principle to memorize and to implement, internalize it, in a lot of ways, it's simply an extension of open-closed principle, as its way of ensuring that all the derived classes extend the base class without changing the behavior of it. Okay. So with the Liskov substitution principle, as stated, is the most important principle to adhere to in object-oriented programming, and given by Barbara Liskov in 1987. And this just states that the child classes or the subclasses, they must be substitutable for their parent or their superclasses. In other words, the child class must be able to replace the parent class, and this has the advantage of letting you know what to expect from your code at one point. Okay. So that is what this Liskov states. So an example of what Liskov looks like here, as you can see, I have a few classes on animal. Like I have an animal and in it I have a method. Then I have dog class extending the method, the make sound. Then cat extending it. Okay. And in cat I have another method which is make animal sound. And then I'm making simple, what do we say, objects over here, and then extending make animal sound from it, from animal. Now what is happening is that dog and cat classes can successfully replace the parent animal class. Okay, now let's just run and see. This is lsp.js. Okay, coming back to LSP. Okay. Now dog and cat class over here, it can successfully replace the parent animal class. Okay. But if you look at the, the theta one, theta is giving me just the make sound from here. Now there is another extension which I want to show you. Let's say there is another class bird extends animal. And here I want fly to be there. Okay. Sol.log. This dot name flies. Let's say. Okay, this is an extension of your animal class in bird. Now I'll make const p equals 2 with new bird. You might have all done in programming, but where it is applied, you might not be sure of that. Okay, so const p, I'll say this is parrot. And then I am calling this make animal sound. This is a different function. Okay, make animal sound. And here I'll pass this p. Then I'll do p dot fly. Again, run it. 29. Now you will see parrot makes a sound and parrot flies. You're getting that answer. Now what here happens is this bird class that we have, it violates the Liskov substitution principle because it's not implementing its own sound, or you could say make sound. Ye jo method hai, this particular method, it's not implementing that from the parent animal. Instead, it's just inheriting the generic sound. The generic method that I have, make animal sound, it's just using that one. Now to fix this problem over here, you have to put the make sound. This make sound has to go inside. When you're extending, you have to extend the methods also which are there and give its own implementation. If you're not doing that, it basically violates the this Liskov substitution principle over there. Okay. Now I'll chirps. Okay. Lest everything is same. And now you'll see that parrot chirps. Okay. Here, parrot chirps. Now it's giving you the correct implementation of it. So this is what substitution principle, it states that the child class should be able to extend the behavior of the parent class, and also it should be substitutional. That, in place of animal or in place of a parent class, you can simply just derive all what you want from the child class itself. Okay. Now, following this principle, it helps us to avoid unexpected consequences of changes and avoids having to open a closed class in order to make changes. So it leads to easy extensions of software. And while it might slow down the development process, this particularly avoids the issues during some updates and extensions. So this is your Liskov substitution principle. The next which comes is interface segregation principle. Now, the general idea of interface segregation principle is that it's better to have a lot of smaller interfaces than a few bigger ones. Segregation principle is that you can have a lot of smaller interfaces than a bigger one. Martin says that make fine-grained interfaces that are client-specific. Clients should not be forced to implement interfaces they do not use. Okay. Now, for software engineers, this means that you do not want to just start with an existing interface and add new methods into it. Instead, you start building a new interface and then let your class implement multiple interfaces as and when required. Okay. So smaller interfaces mean that developers should have a preference for composition over inheritance and for decoupling over coupling. Now, according to this principle, engineers, they should work to have many client-specific interfaces, avoiding the temptation of having one big general purpose interface. Okay, so what you need to do is you need to have many interfaces and not just one that takes everything into it and you work with it. No, okay? So that is your interface segregation principle. Now, this interface segregation is fairly simpler fairly similar to your single responsibility principle, but it's not just a single interface doing only one thing. It's about breaking the whole code base into multiple interfaces or components. Okay, now think about it in the same manner as you do while working with front-end frameworks. If you have like libraries of React, Vue, etc. So what do we do over there in React? If you might have worked on React, we for the whole the project that we are building, the application that we are building, we break it down into smaller components. You remember class components or functional components, and we usually break it down into code base into different components. Or you only bring a component in when you require that. This means that you create individual components that have functionality specific to them. Yes. Now, the component which is responsible for implementing scroll to the top or, to bring in some effects into it, like to effect from light to dark and something, those are all different. And whichever component you require at one point to bring that in and use it. Okay. So now over here right now, what do I have? It's a code which violates the interface segregation principle. Okay. Now, this particular code that we see right now, it violates the ISP because here the fish class, it doesn't need the fly method. Still, I've put fly because fish doesn't fly, right? Birds, again, birds cannot swim. So the bird doesn't need the swim method, right? So those things which are not required by the class, it's still they are getting used. I mean, like those are useless. You don't need them. Why to do that? Yes or no, right? So we need to separate this. Ab separate kaise hoga? Now here what I can do is the fish, I'm removing these. Commenting them out so that you see the difference. Okay? Now I need to implement the methods they need. You need to implement the methods they need. You just created an interface over here. The const bird, new bird, okay, TT the parrot. Now bird.swim. Okay, we are making them implement. Fish does not fly. Birds does not swim. Okay. Now what should be the thing over here? What do we need to do? You need to implement the methods which they basically use, right? So swim here, the fly here, and then you are going to make the changes into it. Okay, that is the change that you want in it. Birds, they do not swim. Birds fly. Fish, they do not swim. A fish, they do not fly, they swim. Those changes. And the changes here as well. Okay. So only the methods which are, or the functionalities which are relevant, only they need to be utilized. Okay, not all. ISP.js. Okay. So now you know that he's flying and swimming. Obviously, you write that, name and everything. So then it give you the correct one, or right. Okay. So you'll see bird is flying and fish is swimming. Cool. So now the one thing that it states that only those methods in the interfaces, they need to be utilized or used which are relevant. Others, they do not need to be used over there, because fish, as you can see, it doesn't fly. So similarly, in your code base, in a project, there'll be some functionality which is not used at the place. Why you want to, use that, or maybe even write it, because that is a redundant thing that is not utilized. Okay. Then the last one that you have is dependency inversion principle, which is DIP, and it's about decoupling your software modules. Okay. That is making them as separate from one another as possible. So this principle, it offers a way to decouple your software modules, and simply put, it's just like, how the developers put it, like depend on abstractions and not on concretions. Okay, that means high level modules should not depend upon low level modules. Both should depend on abstractions, yes. Okay, so that is the dependency inversion principle. And one popular way to comply with this principle is through the use of dependency inversion pattern. Although this method is not the only way to do, whatever method you choose to utilize, finding a way to utilize this principle will make your code more flexible, agile, and reusable. So this principle, again, it states that, higher level modules should not depend on low level modules. Instead, they should both depend on abstraction. Additionally, abstraction should not depend on details. Okay, but details should depend on abstraction. So in simpler terms, this means instead of writing a code that relies on specific detail of how lower level code works, you should write code that depends on more general abstraction that can be implemented in different ways. This makes it easier to change the lower level code without having to change the higher level code. Okay, that is what your abstraction usually does. Now I'll show you an example of which violates dependency. Here, class animal, then dog is extending animal, it has a method bark into it. Then cat has another method which is meow into it. Then you have another function, in class, which is your print animal. It's a generic function that you have. And then you are printing it out. So let's see, what do we get? It is PIP. Jack and Zoe is what we are printing out the names. Okay, now what is happening over here? What is happening in this code? The code here, it violates the DIP principle, because this print animal name function, it depends on the concrete implementations of dog and cat. Okay, this print animal, it depends on concrete implementation of dog and cat. If now I wanted to add another animal, let's say I want to add lion over here, Now I need to modify this print animal. Okay, I need to modify this print animal if I have to add another into it. Now what can be done over here? What can be done over here? So here what I can do, I can simply just create a method inside an animal, okay, which is going to give me the names. Okay, so I can simply just create get name, which is going to give me the names of the animals, and return this dot name. Okay, now after doing this, my dog is extending fine, no, not a problem. Then in print animals, I have animal names. Okay, and this should be here. I'll make the change animals dot length, animal 1, the I, and this should be get name. So now with this, I can have any animal added to it, right? Now, const animals, where I'm adding the names, I can give any different kind of name over here. Let's say I add a lion. I will not define lion. So similarly, you'll have to create goes to new lion and give a name to it. And then you'll have to create the extend this particular, class for it. Okay, now you've got it. So simple, what you are doing is you are creating the classes. You have taken in a name over here, which would be kind of, will not take in concrete implementation, but it's going to be based on abstraction over here. And if you want to, add any other animal into it, you're simply going to add a class and just make the changes in the call, okay, where you are calling all the animal. That is only the change that you need to do. No other change in other part of the code needs to be done. So now what you've done is, now coming towards the end of our discussion is, you learned what solid design principles are, and we discussed each principle with an example and went through ways to implement them in JS, right? Now this, after this, you should be able to identify these principles whenever you come across them. So implementing solid design principles during development will lead to systems that are more maintainable, scalable, testable, and reusable. So in current environment, these principles are used globally by engineers, and as a result, to create good code and to use design principles that are competitive while meeting industry standards. Okay, so it's essential to utilize these principles over there. Remember one thing, whenever implementing these principles, it can feel overwhelming at the first glance. Regularly working with them and bringing them in the habit, I will make you understand the difference between the code that compiles with principle and the code that does not, will help to make good design processes easier and more efficient. So this brings us to the end of a session. Before we end, I have a poll coming up for you. Pritesh, can you please help me with a poll?
Yeah, sure, Swati. So, yeah. I'll just read out for everyone. What does S in solid stands for? Simple responsibility principle, single responsibility principle, or single response principle, and simple responsibility plan. I would request everyone who's present here to actively participate in the poll. It will give us a fair idea whether you have understood or not. So go ahead and answer the poll. Okay, I will be closing the poll. Everyone just quickly answer. Perfect, perfect. Okay, so most of you have answered it properly, and everyone here has participated. Thank you so much for that. And now this brings us to the end of this webinar. Thank you so much, Swati, for this amazing webinar. I hope everyone really understood a lot of things. And thank you for taking out time. Are there any questions? The forum is open. You can use the Q&A sections to ask questions. And we have Swati here who can, answer any technical questions that you have. Perfect, perfect. So if we have one question, can you explain Liskov principle in short term? Swati?
Yeah. Oh, I'm so sorry. Okay, so the Liskov principle. So now the Liskov principle, it is based on data abstraction, and let's be honest, the scientific the way that it was explained, from classes to subclasses, this defines that objects of a superclass, it should be replaceable with objects of its subclasses, without breaking the entire application. That requires the objects of your subclasses to behave in the same way as the objects of your superclass. So if at any given point you can do each and every functionality which was present in the superclass through just your subclasses, that is your Liskov substitution principle, where your subclass can take over and substitute for your parent class and can be utilized to access all the methods and functionalities of it. Some of the, you could say rules that go by in this is that if there is any overridden method, of a subclass, which needs to accept the same input parameter values as the methods of this superclass. So now any overridden method which is in this subclass and is also in the superclass, that means, and have the same parameters, they are going to function in the same manner, right? That means you're extending all the functionalities of a parent class into a subclass. Any other question?
Okay. So if there are no more questions, I will just wrap up this session quickly. So thank you again, everyone, for joining in for this wonderful session on a Saturday morning. And okay, Neha says, can we get the recording of this webinar? Okay. And I will just check with the team. I will just launch one more poll for everyone, okay, wherein we will understand if someone is looking for better understanding of programming or wanting to get started with their tech career. But before I do that, I would like to just highlight certain points about Unique Aksha and how we can help you get into top tech companies. So basically, Unique Aksha is an upskillment platform specifically designed for professionals and students, where we help people to get into top tech companies through a 4-month program. Okay, so we have a 4-month program in which our key USP is that we have industry experience working on large scale projects and working with top tech companies. These are the people who are going to guide you and give you that hands-on skills that is required. Right, so you get to learn from the best of the people in this industry. Secondly, we offer 100% live classes because we believe that when you are interacting, and we believe in two-way communication when you're learning, so that is also one of our key USP. And thirdly, this is 100% job guarantee program. So it's not like after upskillment, we ask you to find a job for yourself. We take that responsibility that once you are enrolling with us, we help you till the last mile and getting you a job. All right. So these are just few of the USPs. There are more to it. All right. If someone is interested in knowing more about the program, I will launch a poll where you can simply write yes or no, and then we ask someone from the team to connect with you. Sure. So okay, I'll be closing the poll. So just quickly answer. Done. Okay, then thank you so much for connecting once again. All right. And we'll connect again on the next Guru class. Till then, thank you so much and bye bye.